we're going to have to graph all of our log functions and all the transformations with them. Now, temporarily, to graph log base 4 of x, you can say log base 4 of x is the inverse of an exponential function. So if I can graph y equals 4 to the x, because I've done lots of exponentials already, and I know it has an asymptote at y equals 0, and I know the key points are 0, 1, and 1, 4. If I can do that, then I can easily graph y equals log base 4 of x because they're inverses. And if they're inverses, that means instead of 0, 1, I'm going to have 1, 0. Instead of 1, 4, I'm going to have 4, 1. And instead of having an asymptote at y equals 0, if you switch x and y, instead of y equals 0, I'm going to have x equals 0. And if I have x equals 0, that becomes a vertical line. What do we know about asymptotes? Asymptotes are what your graph approaches. And so at the beginning, at the very beginning, and I hope this is going to end in about 2 minutes, the beginning, for you guys. At the very beginning, you could always graph the exponential function, think about the line y equals x, switch the x and the y, and graph your log function. Now that we've done that for 30 seconds, now, though, I want you to know that the log graph always has that shape, and that you always have an asymptote at x equals 0. You always have the point 1, 0, and the base 1. And you have all of your log graphs in your head as parent graphs as well, just like you have all the exponential graphs in your head. So know what the shape looks like and be able to graph a log directly. Okay? So I'm going to say, as another example, if you were asked to graph y equals log base 7 of x, you would right away draw your asymptote here, add the point 1, 0. That doesn't look like a comma. And because the base is 7, you would have the point 7, 1. And you'd be able to just graph it directly. There's no need to graph y equals 7 to the x first. So when we have a log graph, we know that it has this shape and it looks like this. Even if, now this is very rare on the exam, log base 1/2 of x, but just in case it happens, we're going to have the point 1, 0, just like always. And we're going to have the base 1. But 1/2, 1 would be there. You still have the asymptote at x equals 0. But based on those points, can you see in this one, it would look like that instead of going up. Just like how in exponentials, some of them are increasing and some of them are decreasing. So too with logarithms, if your base is between 0 and 1. Now, it almost never happens on the exam that they give you a base between 0 and 1 with a logarithm. 99.73% of exam questions have the logs increasing from left to right. But going back to the question we were doing, there's our graph. Identify the intercepts. There's an x-intercept. There are no y-intercepts. What's the equation of the asymptote? We've got it labeled at x equals 0. This question also asked us to say the domain. The domain is x is bigger than 0. The range is everything. Actually, we're not going to do an example 5. I'm just going to add a part C to this one. So part C, and if you're running out of room on page 379, you can put part C at the bottom of page 378. And we're going to graph y equals ln x. Anybody know what ln stands for? The natural log. It's French, log naturel. That's why the L's first, then the N. But yes, ln is the natural log. Now, the common log is, right, we learned about the common log. The common log is log x. It's the same as log base 10 of x. It's so common that mathematicians said, we'll call it the common log, and is everybody okay with not writing the extra 10 to save us some time? And everybody's like, yeah, we're good with that. So the common log happens enough times that they're like, we want to take a shortcut and not write that 10. The natural log is exactly the same as log base e. And it happens enough times that they decided to have its own letters to represent it. I mean, look how long it takes to write log base e. You're writing 1, 2, 3, 4, 5 letters. That's longer than some of your names. But if we change it to ln x, we only have to write 3 letters. Saves us tons of time. So the natural log of x is just log base e of x. And if you were going to graph it, well, it's a log graph. The rules for graphing log graphs stay the same always. You're going to have the point 1, 0. You're going to have an asymptote at x equals 0. And the other point that we always graph for logs is the base, 1. What's the base? The base is e, so we would have the point e, 1. Right? E is a roughly 2.7, 1828, 1828. You've memorized it to 9 decimal places, I hope, already. Okay? And has exactly the same shape as all of our other log graphs. So the questions for practice are 10 and 11.